All right, problem 2 says a manufacturer wants to produce a box. I'll start by drawing a box. Wants to produce a box that has a base that is twice as wide as it is deep. So we're going to call this right here, that'll be its width. So the width is 2 times as wide as it is deep. So if this is D, then W is going to be 2 times that. So that's helpful. W is 2 times D. And it has a surface area of 114 square inches. So up above, we actually had a formula for what the surface area would be for something like this. And it was basically 2dW plus 2W. Oh, and let's say the height of this box is h. WH plus 2h times d. Okay, so actually this is nice because I know that W is equal to 2D, so I can actually make that substitution. Now the reason I'm doing that is there's a lot of variables here, and I'd really like to narrow it down so that I have like just one variable, because that's what we know how to do, is one variable at a time. So everywhere I see a W, I'm going to plug in 2D. So 2D times 2D plus 2 times 2D times H plus 2HD. So I think I can simplify a teensy. 4D squared plus 4DH plus 2DH. Oh, and these are the same, so I can simplify more. 4D squared plus 6DH. So far, I'm just kind of narrowing down what I've got. Let's read the problem one more time. A manufacturer wants to produce a box that has a base that is twice as wide as it is deep. Okay, so I did that. And it has a surface area of 114 square inches. So I use the information I have to get that 4D squared plus 6DH equals 114. What dimensions will produce a box with the maximum volume? What is the volume? So I want to find the dimensions that will produce a box with the max volume. So my objective is to maximize volume. And I know how to find the volume of a box. That's just D times W times H. So that's the equation I want to maximize is F of dWH. So I think it would be a good idea to try to narrow this down to one variable. So with this equation here, I've actually got two things I can do. So with this equation, I can replace all of my W's with two D's. So I'll do that. So D and then W equals 2D and then times H. So I think I'm going to end up using the variable D here. I'm going to narrow it down to the variable D. So I could take this equation here and solve it for H, and then I would get D by itself, and I could plug it in here. So let's do that on the side here. So I have 4D squared plus 6DH equals 114. So if I want to get H by itself, I'd subtract 4D squared. And then I could divide by 6D. Oops, that's a D. Okay, now if I plug this thing into here for h, that gives me one equation with one unknown. So 114 minus 4d squared all over 6d. Now, I think it would be a good idea to try to simplify because that looks pretty crazy at the moment. Oh, and I put a derivative symbol, but it's not a derivative. I haven't taken a derivative yet. So f of d would be, so I have a d on the top here and a d on the bottom that could cancel. And 2 and 6 could simplify to just divide by 3, or 1/3. So I get 1/3 d times 114 minus 4d squared. And I could even multiply that out farther. 1/3 times 114d minus 4d cubed. Cool. Okay, so I want to recap what we've done so far, and then we'll pause so you can take a second to think about it. So the first thing we did is we drew this picture here. And from the picture, we got a couple of equations, and the text. We also know that the width was twice the depth. And then we also knew that the amount of surface area was specifically 114 square inches. So the manufacturer wanted it to be exactly 114 square inches. That's all we had to work with. So we were able to take the surface area equation, which is right here, and set it equal to 114 inches. So that gives us two things that we were then able to narrow down our equation, our objective, to one variable. We used these two equations to narrow our objective equation down to just the letter D as a variable, and that's very helpful. So if you have any questions, please ask them on the discussion board.